Welcome to this demonstration video. Today, we'll walk you through how to use the Model Context Protocol, or MCP, provided by MegaEase Cloud, together with the VSCode plugin called Cline, to automatically manage cloud resources using large language models. The GitHub project link is included in the video description below. Feel free to check the documentation for more details. Before we begin, let's first understand what MCP actually is. MCP acts as a bridge between large language models and various backend service resources. In order for an AI agent to perform different tasks via a language model, it needs to call the appropriate backend APIs. For example, booking a flight requires the airline's API, and route queries rely on a mapping API. These APIs come in various formats. Some are HTTP requests, others are RPC, or even local command executions. Without MCP, the language model would have to adapt to all these different formats, which increases training complexity and reduces the agent's execution accuracy. MCP was created specifically to solve this problem. MCP defines a standardized JSON-based format. As long as the language model follows this format, it can call various backend resources and tools to interact with them. Meanwhile, backend services, regardless of how they are managed or invoked, only need to create a corresponding MCP server. This server converts their APIs into MCP-compatible tools and resources, making them easily accessible to the language model. With that in mind, let's use this example to walk through the entire workflow. First, MegaEase Cloud Service allows for convenient management of cloud servers. You can create, start, stop, and monitor various middleware services. All operations to MegaEase Cloud Service are done through HTTP requests. The web frontend generates corresponding HTTP requests based on user actions and sends them to MegaEase Cloud for execution. At this point, we need to implement an MCP server that converts these HTTP requests from MegaEase Cloud into MCP protocol format and provides the corresponding tools in MCP format. Next comes the role of the MCP client. It connects the MCP server, the large language model, and the user. The MCP client sends both the user's input and the MCP formatted tools from the server to the language model. In this setup, the language model functions more like a rule engine. It understands the user's request, examines the available tools, decides which tool to use and how to use it, and then instructs the MCP client to trigger the corresponding tool on the MCP server with the appropriate inputs. The MCP server then calls the appropriate backend API based on the tool and input. In this case, it sends HTTP requests to MegaCloud. The result of the execution is sent back through the MCP client to the language model, which parses the response and returns it to the user in natural language. In this way, the language model gains the ability to operate backend APIs of various formats through the MCP protocol. This significantly enhances the AI agent's capabilities, allowing it to easily interact with different backend services and better serve users. Now let's start the demonstration. First, we log into the MegaEase Cloud Console, where we can see that there are currently 3 servers, and among all the middleware, only 2 deleted Redis instances remain. Next, we open VSCode to begin the local demonstration. Search for Cline in the extensions marketplace. Open the Cline plugin and click the MCP icon at the top right to enter the configuration page. Under the Install tab, we select the local setup and open the Cline MCP settings.json file. Here we fill in the MCP server address and add the authentication token MegaCloud auth token. Note that this address should be replaced based on your deployment environment. The auth token can be obtained by logging into MegaEase CN and inspecting the network requests in your browser. After completing the configuration, we begin interacting with the large language model. We first ask the model to list the currently available hosts. The model calls the List Available Hosts tool and returns the information of 3 hosts. Next, we ask the model to help create a Redis cluster. Initially, the model suggests a 3-node setup. We specify that we prefer a 2-node architecture, and the model immediately adjusts its deployment plan and automatically corrects a naming error. After executing the deployment command, the model recommends checking the current status. We can see that the Redis cluster is in the process of being created. Since middleware deployment usually takes some time, we can skip ahead for now. A few minutes later, we check the status again. We can confirm that 2 nodes have been successfully deployed. Building on that, we instruct the model to identify and use servers and add a Redis master node on an available host. The model calls both the add Redis nodes and get middleware info tools to add the node and verify the current instance status. We then decide to remove the newly added node and return the Redis cluster to a 2-node structure. The model accurately executes the deletion command. Finally, we ask the model to stop the current Redis cluster, and the resource status is updated accordingly. With that, the entire process of automatic deployment, scaling, status checking, and instance management comes to an end. To summarize, with the help of MCP, the process of interacting with backend services becomes much simpler. Users no longer need to open web pages or learn different interfaces. They can complete backend operations just by expressing their intent through conversations with a large language model. This greatly lowers the learning curve and enhances overall convenience. In the future, we may no longer need multiple apps or websites. An AI agent might be all it takes to handle various tasks and queries. That concludes today's video. If you'd like to dive deeper into the MCP protocol or the configuration details of the Cline plugin, feel free to visit the project homepage or check out the official documentation. Thank you for watching.